So we are looking at linear programming. Okay. And
Yes.
I'm sure you guys are doing computer science, right?
Yeah.
There are some who are not doing computer science.
All of us are doing computer science.
Okay, so we are going to look at linear programming. Okay.
Mm.
And when we talk of linear programming, there are basically two words there. There's linear and there's programming. Okay.
Yes.
Linear comes from word line. When we talk of a line, who can tell us what you understand? If someone says this is a line, when you look at a line, what comes to your mind? If someone says this is a line.
A line is something which is straight.
Okay, according to you, it's something which is straight. Anyone else? Anyone else? Okay. This is what I've drawn on the screen.
Yeah, I've seen.
Is that a line?
Yes.
Is it only one person in the class? I'm hearing only one person talking.
Others have not yet joined, I think.
But I'm seeing 5 people online. I'm seeing
We
5
are around,
people.
sir.
Hmm?
We are around.
Okay. Do you see what I have drawn on the screen?
Yes, we are seeing.
That one which is moving.
Yes.
You define that as a what?
A straight line.
Forget about straight, but I think the issue is it is a line, right?
Yeah.
Now, after being a line, yes, it's straight. Okay. But when you critically look at it, it has a starting point. Do you see the starting point?
Yes.
It has a starting point and it has an ending what?
Ending point.
An ending point. Okay.
Yes.
So when we talk of linear programming, this means in programming, we are going to have a starting point, and in between there are a series of activities, and then at the end, we shall have an ending point. So we are going to begin somewhere and we are going to end somewhere, like a line. It begins somewhere and ends somewhere. So that's what we call linear programming. We are going to do programming, but in a linear way. It means we are going to have a starting point and we are going to do a series of activities. We are going to write expressions. We are going to write statements. But at the end of it all, we shall have an ending point. Okay? As we are going ahead, we shall be talking of barriers. We shall have a starting point and ending point. So we shall have some barriers. So when you go to the second slide there, can someone read for me those in quotes? The first 2 sentences, can someone read them for me?
Every day,
Yes.
businesses, governments, and even apps on your phone face the same question. How do we get the best results with the resources we have?
Okay, so people in business outside there, okay, they are challenged. They have resources, right?
Yes.
Yes.
They have resources, but they want to get the best out of these resources. I can give you a simple example. Have you ever thought of the mobile money app? Mobile money app.
Yeah. Yeah.
Yes, people had money, people had phones, okay? But to access your money, you have to walk long distances to go to the bank, okay? Or even if you wanted to send money to your mother in the village, you either have to put it in a bank. Sometimes the bank is not open on weekends, on public holidays, or even you have to board a taxi or a bus to take the money, which even you can lose in town, okay? So people had a lot of questions. okay, with my phone, how best can I use it? And these are the questions which are still happening every day. Businesses, even these mobile phone companies, the banks, okay, the government itself, okay, people have traffic jam in town, okay. So the question is, with the resources we have, how can we calm down this traffic jam which we're having on these roads, okay, with these resources? So many questions are coming in the minds of people. How do we get the best results with the resources we have? Okay. It's even you, the students, you have come to Nkumba University to study, right? But I'm sure now the questions running into your heads, how can we get the best results with the lectures we have been given, with the lecturers we have been given, with the notes we have been given, okay? With this book they have given us to read, okay? Soon I'm going to give you a textbook we are going to use. So also you're asking yourself, how do you get the best resources, the best out of these resources? I have seen on your group someone was telling people that people should learn how to read notes and understand them, okay? So again, also is pointing at how do we get the best out of this resource the lecturer has given, okay? So linear programming is the language of smart decision making, okay? So all of these questions we are asking ourselves, all of these questions we are asking ourselves, business people are asking themselves, governments are asking themselves, okay? Even you, the students, are asking yourselves. So linear programming is the language which is going to help us to answer these questions. So linear programming is going to help us to make smart decisions, okay? Like you see, you have heard things like smart city, smart agriculture. Have you ever heard of such terms? If someone said smart city, what do you think it means? If someone said smart city, yes? Innocent, are you telling us?
No.
Have you ever heard of the term smart city anyway?
Yes.
And what came to your mind? Okay. So these terms have been used already: smart cities, smart agriculture. Okay. So here, when we come to linear programming, we are the answers to smart city. We are the answers to smart agriculture. Instead of using traffic lights on the road, as a student of linear programming, you can come up with a code which can put up traffic lights. Okay. And that is smart city already. So it turns real world challenges into clear models, like the real world challenge of traffic jam in the city, okay? And those models into optimal solutions. When we talk of optimal solution, we look at something which is the best, okay? The maximum good, okay? So from scheduling, that is an example of scheduling flights, like you saw on the airport. There is a system which schedules flights so that these planes don't crash in the air. This plane knows that this is coming in this direction, so this takes in this direction. Have you ever sat somewhere? Those of you who have taken planes, have you ever asked yourself why when you're in the air there, you can never find another plane, but they are there? But have you ever seen one plane when it is bypassing the other one? Like here on the road, you see cars bypassing, and this one overtakes. Have you ever seen a plane overtaking another one? Yeah.
Oh.
But what controls them? Why don't they take the same direction and they overtake like you see the cars? Have you ever seen a traffic jam of planes in the air there? At least those who have never flown out of the country, you may never know this, but those who have, okay, these are some of the questions which ask ourselves, okay? How does this one happen? Okay, so we are students of computer science. These are the challenges ahead of us. This is why you have come into the course of computer science. Okay, you have come to change the world. You have come to solve problems. Okay, And the only way you can do this, the only way you can change the world as a student of computer science is by doing programming. Okay? By doing programming. That is the best way you can do it as a student of computer science. Okay? So when we talk of linear programming, that is what is ahead of us, writing codes. So if you can master linear programming, you don't just solve problems, okay? You don't just solve problems, but you engineer the best possible outcome. And in the tech-driven world, that's not just a skill, it's a superpower. It's not just a skill. People are going to fear you. The mere fact you tell your fellow students that I'm doing computer science, they even run away from you. Some of you, they even think you are mad, especially when you start writing codes. When someone looks at a code you have written and what comes out in good colors, people will say, how does this guy write this? How do you understand what you're writing? And how does it bring it out? Just look at the traffic light. Can you imagine if you came across someone who wrote that first code of the traffic lights? Wouldn't you be amazed? Okay? But someone just sat down and wrote a code. Okay? If you come across someone who wrote the first code of a mobile phone, you'll be able to be in Uganda and you call someone in America. There and then you talk to the person live. Don't you think it is amazing? Can't you fear such a person? So I urge you to get serious. Get serious. If you're going to be a programmer, forget about these childish things I've been seeing in the group. People are writing, yeah, man, that's not a programmer. A programmer is a well-serious person, well-behaved. He has a very organized mind. Because your mind, if it is organized, you're going to well organize the code, and the code which is going to change the world. Okay? You have seen robots. Okay? These have been written by codes which have been written by computer science students. You have seen robots. Okay? So if you're in this thing, you'll say, yeah, man, these things, talking like a hooligan and so on the group. If you don't want to exist, you can never be a programmer. Okay? Programmers have well-behaved minds because the code you are going to write is going to reflect what the world is going to move on. And that's why we are saying in the tech-driven world, it's not just a skill that you are going to attain, okay? But a superpower. People are going to treat you with respect until when you disrespect yourself, like the way some of you are disrespecting yourselves on the group, okay? So be mindful of from today, be mindful of what you post on the group. Some of us will read your heads and we say this one is head, okay? Many of you, I actually have not met any of you, but now I can tell who has a corrupted mind and who was brought up in the well-to-do family, who is a good student, who is a wrong character in the group. I can tell because of what you type on the group. So programmers, we are people who are going to change the world, okay? Our minds should be minds which are going to change the world, not to disorganize the world, okay? So we have very important terms in linear programming, very important terms, which we are going to use. And these ones, we call them elements of linear programming. Elements of linear programming. So we shall come back to this, but we have what we call the decision variables. Again, you see, in programming, there will be a lot of making decisions. And the decisions which you make are logical decisions, mathematical decisions, calculated decisions. You don't just talk like a hooligan, okay? You organize what you are going to say. That is linear programming, decision variables. Variables means it varies. Yes, you have the choice to use that word, and you have a choice not to use it, okay? Before you come to the group to say, yeah, man, it means you have a choice to choose. Now, when you choose to use yeah, man, of all the words, if you choose to use yeah, man, then you are telling us which type of person you are. Okay, so decision variables. We are going to use a lot of variables to make decisions. And it is you, the programmer, who's going to choose which variable to use, which word to use. Then we have objective function. Objective function is what you want to achieve. Okay, we shall come back to these things later. Then we have bounds. Bounds, that is the limit. Like we saw the line. It has a beginning and it has an end. Okay, so it has a boundary. Like when you come to Nkumba University, the university has a boundary which is the walls within you. That is what we call Nkumba University. Outside is not Nkumba University. Then we have constraints. Constraints, these are some of the challenges that may stop you from doing something. For example, if you're a Muslim man, the constraint could be a man can marry 4 women, but one Muslim woman cannot get married to 4 men. That is a constraint. If you're Catholic, a man, you get married to 1 woman, and 1 woman gets married to 1 man. That is a constraint. As long as you choose to be Catholic, it means you're going to marry 1 woman and 1. That's a constraint. It is a limit. Okay? Then we have optimization. When we talk of optimization, that means the maximum good. Maximum good. Okay. That was a preamble. Now let's begin the real linear programming. Any questions so far? Am I audible? Can people hear me?
Yes, we can hear you.
Okay.
So, also this thing is too hard.
Sorry?
Like you somehow fast.
I'm too fast.
Yeah, like you somehow fast. You're not picking some things.
Yeah, I'm too fast because I gave you these notes long ago. I thought you went through them.
Yeah, but the term seems to be complicated.
The terms seem to be complicated.
Yeah.
Yeah, because you're also a complicated student. You call it a joke to be a computer science student.
I'm sorry, sir.
You're also complicated. That's why you chose computer science and never chose Bachelor of Arts.
Okay, sir.
But don't worry, these terms are going to come clear as we go ahead. Okay? I know at
Sir,
the
thanks.
beginning, it's like when you are learning a new language. Okay? Now look at programming as a language. Like if you're in Uganda and they tell you are going to learn Lugubara, the first 3 words you're going to learn in Lugubara, you some dead. Will I ever learn this language? But with the time, you start laughing at yourself. Now, why was I fearing? Okay, this is a language. Okay, if someone told you today that you are going to start learning German, and they greet you, they use the first 3 words in German to greet you, you'll get scared. You say, "My goodness, will I ever learn this language?" But with the time, you laugh and you say, "Now, what was difficult here?" And also be laughing at the learners, and you say, "Now, you people, what is difficult here?" So, my brother, don't get worried. Okay. Always the beginning is tough, but with time we are going to break down these terminologies. All the terminology I've mentioned, we are going to see them into details, and I'm going to break them down. Are we together?
Yes, sir.
Okay, can someone read for me the first statement there? First paragraph.
Linear programming is viewed as a notional development, giving man the ability to state general objectives and define, by means of simplex method, optimal policy decisions for a broad class of practical decision problems of great complexity. In the
Okay,
real
so,
world,
okay, first stop there. First stop there. When we look at this statement, it says linear programming is viewed as a revolutionary. That word revolutionary means it is going to change. Okay. When we say we are bringing a revolution, okay, it means we are bringing a change. Okay. Today we hear people like the new people. Okay. They say we are bringing change, a revolution. Okay. Revolution means we are going to change things. So when you talk of the moment you talk of linear programming, the moment you say I'm a student of linear programming, we look at you as a revolutionary in technology. It means you are going to change technology. Like today we have the traffic lights, okay? But this, someone maybe programmed them 20 years back, wrote that code 20 years back, okay, of the traffic lights. But for you can come up and you say, well, I'm going to revolutionize the way these lights work. And you change. Recently, we had traffic lights now which give penalties. Okay, in abroad, like in the UK and America, these things are already there. But our traffic lights in Uganda were not giving penalties. But of recent, we had the traffic that when you pass on the lights, it's going to give you a penalty and it's going to go to your driving permit. That's a revolutionary. Okay. So as a student of linear programming, we look at you as a revolutionarist, a person who's going to change, who's going to do change. So development, giving man the ability to state general objectives. Okay. So you can set objectives and you say, what I'm going to do is going to achieve this. And then by means of the simplest method. So we don't want you to use complex methods, okay? We don't want you to use complicated methods to solve problems. If I give you a mathematical number and I say 3x plus 4y is equal to 5, and I tell you find y, okay? So I expect you to use the simplest method to find y. Altogether, I don't expect you to use a complicated method. Then optimal policy decisions. When we talk of optimal, it means we get the best solution, the best decision out of the complicated reality. So we get the best solution out of it. So in the real world, planning tends to be ad hoc because of the many special interest groups planning. So in the real world, planning is difficult. You sit, I can see you're about 6 in your class, okay? Or even 10, okay? I can ask Innocent, can you tell us when you told the group that the lecturer won't be able to teach in the morning and said he opted for online lecture? So you wanted decision from people. Can you tell me how easy it was for you to get the consent of people to come for this lecture? Innocent, was it very easy?
Yeah, cooperative.
They were cooperative. But I'm
Yes.
sure some of them told you at that time I will be sleeping. Because in the group I already saw someone say, "May I want to sleep?" Okay. I know, Innocent, you don't want to tell me the truth. But I'm sure some people told me, for me at that time I'll be sleeping, for me I'll be in the bar, for me I can't attend lectures at night. Then later on, you found a way of convincing them to attend this lecture. Okay. Also, I didn't want it this way. But at the time you were supposed to have the lecture, I had not foreseen that I had an appointment with a doctor. And at the same time, I had to drive to Namagunga to pick my daughter. Okay. So all along, I thought maybe by 7 I'll be back. But the jam on Ginger Road, I tried to dodge the jam, but still, you see how planning is complicated. Okay. So I tried to do until when I said, people, I can't make it at 8. Let us make it 8:30. And I saw someone say after 8, then they'll say 9. Then, planning is not easy. Okay. Because of the so many special interests. Now, as me, I'm on the road, my interest is to reach in time and I teach my students. Someone also is on the road, his interest is to stop you so that the president passes. You are not going to, for me, I'm rushing to teach students. Okay. So people have different interests and we have different groups with different interests. Okay. So there are multiple objectives. Everyone has what he thinks is okay. Then because everybody on the road has a different interest, then a traffic officer comes in. Because if everyone has his own interest, everyone wants to pass. So a traffic officer comes in to put together these interests. So the traffic officer is now you, the linear programming student, is you, the linear programmer. Okay. So you say, all of you now, you want to go. So you are going to cause jam. So let me program a code which is going to put traffic lights, which everybody is going to follow. So whether you are rushing to teach students, whether you are rushing to find a patient, but as long as the traffic light has put you on red, you stop. Okay? Hope we get that paragraph. Okay, can you read for me the second paragraph? Anyone to read the second paragraph? The linear programming technique was first introduced in 1930 by a Russian mathematician. Now, linear programming, we are students of computer science, okay? But we borrow linear programming from the field of engineering, especially electrical engineering, okay? So those people doing mathematics, basically, they are the owners of linear programming. For us, we just borrow this terminology from them, okay? And we see how they do their things in a linear way, how they solve their mathematical equations in a linear way. That's why we say this technique was first introduced in 1930 by a Russian mathematician. So basically, we are going to borrow the methodologies they use in linear programming, and then we use that knowledge in doing programming. Okay, that's what this paragraph is talking about. So we are going to borrow the way they do it, and then we use it in our field of programming. Any question before I go to decision variables? So I'm breaking now the other terminologies which we said, which were hard. I very much want students to read these things because when you read them, they also make sense to you. Do you have any girl on the group? Any girl on the group? Do you have any girl in the class? I'm seeing Rachel Mbabas. Rachel Mbabas, can you read that? Who is Rachel Mbabas? I know some people have logged in and they're in the ban now, so they don't want us to know them.
Decision variables are physical quantities controlled by the decision maker and represented by mathematical symbols. For example, the decision variable xj can represent the number of pounds of product J that a company will produce during some month. Decision variables take on any of a set of possible values.
Okay, what have you understood from what you have read? Just what comes to your mind when you read that paragraph? What comes to your mind? Okay, just take the first statement. Decision variables are physical quantities. Mark that word, physical quantities, controlled by the decision maker. Okay? And represented by mathematical symbols. Now, let's first forget about the mathematical symbols. Let me give you a scenario. When you were born, okay? When you were born, your parents, either your father or your mother, gave you a name, Rachel, okay? But the name Rachel, he or she gave you, do you think there are not many other names you would have got? Okay? You would choose from, yes? Rachel, if at that time you were understanding and they told you to choose a name, would you choose to be called Rachel?
No.
Be genuine to yourself. Yes, you said no. Okay. But the decision maker at that time was your parent. Okay. Either your mother or your father. Okay. Yes, a pool of names. The pool of names he would choose. Okay. But because he was the decision maker, now these names he was supposed to choose from, those are called variables. Okay. Those are called variables. Now, the person who gave you those names now was the decision maker who was supposed to choose from these varying names. And some of you, if you go back and you ask your parents, they are going to tell you the first week you were born, you had about 20 names. Every person who came to see you gave you a name. Every person who came to see you gave you a name. But all those people who gave you names were not the decision makers. They were not. So the real decision maker was your parent. So let's go back to the traffic lights. When you look at the traffic lights, the actual decision maker who was making the traffic lights was the programmer. So that programmer is the one who chose and said green should say go. Red means stop. Amber means be careful. But unfortunately now Uganda, amber means drive very fast. That's a problem. Orange in Uganda means drive very fast. But according to the programmer, green means go. Orange means be careful, ready to stop. And red means stop. But that was the decision. If this person who made programming, if his decision was red means go, green means stop, that would be his decision because he was the decision maker. Okay? So when we talk of a decision variable, that means that variable has been chosen by the decision maker. In programming, you are going to make decisions. Okay? Like in mathematics, you have heard of those stories. They tell you a carpenter makes 3 tables in 1 hour and 4 chairs in 20 minutes. Okay? Then they tell you, and using a board of 5 by 10 meters. So they tell you, if a carpenter is given a board of 20 by 30 meters, how many tables is he going to make in one hour? And you see, then you start saying, let the tables be X. Now you are the decision maker. You are the one who says, let the tables be X. You are the decision maker. Another student will say, let the tables be Y. Say you are in an exam and you are 30 students. So each student will call the tables, another will call them X, another is going to call them Y, another is going to call them Z, another is going to call them P. But all of you are going to be correct because you are the decision makers. Okay? So as we go ahead in programming, we are going to be making decisions. Okay? So you as the programmer, you are the one to choose what you call that variable. Okay? You are the one to choose what you call that newborn baby. Okay? You are the parent now, you are the one to choose the name. And the choice is yours. Okay? So for example, the decision variable xj can represent the number of pounds of product J. Okay? That a company will produce during some month. I've given an example of a carpenter doing tables. So decision variables take on any of the aspect of a possible value. Okay? We go to another slide. Objective function. Yes, someone read for us what objective function is. Objective function. People want me to mention their names. Ivan. Ivan.
Yes, please, sir.
Can you please read for us what is there?
Objective function defines the quotation for evaluating the solution.
Repeat. It does what?
It defines the it defines the criteria. Master, this word is not here. Is this R or T?
Okay, it should be criteria.
Okay. Objective function defines the criteria for evaluating the solution. It is a mathematical function of the decision variables that converts a solution into a numerical evaluation of that solution.
Okay, you can stop
For
there.
example,
You can stop there. When you say objective function defines the criteria, have you ever heard of a saying which says the end justifies the means? Have you ever heard of such a saying? That the end, who has ever heard of that? The end justifies the means. Okay. So objective function defines the criteria for evaluating the solution. Okay. So you have a solution to the problem. Okay. Yes, we see you have got the solution. Normally in mathematics, when they give you sort of a number, okay, and you just give the answer without giving how you have got that answer, do you think you are going to get a full mark? Okay. So objective function looks at the criteria. Okay. So yes, you have got the solution. We have seen the solution, but how have you come to that solution? Okay. So we want to look at the criteria which you have taken. So in programming, there's a criteria which you are going to use to reach at a particular solution. Okay. And that is now comes the objective function. So it is a mathematical function of the decision variable that converts a solution into a numerical evaluation of that solution. For example, the objective function may measure the profit or cost that occurs as a function of the amounts of various products. The profit, okay? If we say that today, yes, we are selling bread, and we know each bread we get a profit of 500. So if we say today we made a profit of 50,000, so that means we have sold so many loaves of bread in order to get that profit of 50,000. So the moment I say today we have got a profit of 50,000, that means today we have sold so many loaves of bread. Now the question is, what criteria have we used such that tomorrow, if we fail to make 50 loaves of bread, it means we have used the wrong criteria. I don't know if it makes some sense to you. So it specifies direction of optimization, the direction, how we are going to get the maximum profit. Okay. So if we say today our target is to get a profit of 50,000. So now the question is, how are we going to get that profit? Okay. How are we going to optimize? So it specifies the direction, how we are going to get to the solution. So either to maximize or to minimize. So any optional solution for the model is the best solution as measured by that criteria. So if we reach the 50,000, which is our target of profit, it means that that is the best route we have taken. As a student of linear programming, your target, your optimal solution is to pass, most probably with the A. Okay? With the A. None of you would like to get a retake. A retake, that is the minimum. That is the minimal solution. Okay? But the maximum is for you to pass with the A. Now the question is, what criteria are you going to take in order to pass, in order to get a maximum grade, which is A? What criteria are you going to take? Okay? Do you think you are going to just jump and get a A? Okay? So there is a criteria which you are going to take in order for you to maximize, to get a good out of linear programming, to be able to pass, and not only to pass, but also to be able to write codes. And one of the criteria is to attend these lectures, each and every lecture. That is one of the criteria. Secondly, to read the material which the lecturer gives you in class. Like I'm going to give you a textbook. To be able to read, spare time and read. Thirdly, you are going to do practice. Practice. Programming, if you think you are going to be a programmer, if you think you are going to pass this class, you must practice as much as you can. Every day you have to do some programming. Every day. Every day. It's going to be part of you. If you think you are going to study on Tuesday and wait for the next Tuesday, trust me, you can never learn programming. This is something which you have to do every day. Every day you have to spare at least 30 to 40 minutes or 30 to 1 hour to do some programming. Okay. So the criteria is going to determine the end. Like we saw with the line, you begin somewhere and then you move until when you get to the end. So objective function is the mathematical expression that represents the goal of the optimal problem, what you are trying to maximize or minimize. Okay? I think the class is becoming easier, because it's becoming more complicated. Okay, let's look at this example here. We have a mathematical equation which you want to maximize or to minimize. And we are saying Z is equal to C1 x1 plus C2 x2 up to Cn xn. Okay? Now from this equation, when you look at C1, C1 can take on any figure. For example, now for this equation, C1 has been made to be 50. Okay? And then we are saying 50. So we have a graph here. Okay? Remember that graph of X and Y. Okay? In mathematics, in mechanics, those of you did mathematics at HSC, mechanics, we have to plot X and we have to plot Y. Now, if this is X2 and this is X1, okay? Now we are saying we are going 50 on X1, we are moving 50. So move 50 to the right, that is X1, and move 30 upwards, that is X2. So at that point, that is 30, and this point is X1. Now, when you add these 2 points, you are going to have this area, okay? But we can have a constraint, and we say X2 cannot be less than, should be greater than or equal to 0. Then X1 also should be greater than or equal to 0, should not exceed this. So this is the area now which we mean. And these are the bounds which we talked about as a boundary. Now we cannot exceed this point in this direction, and we cannot exceed this point in this direction. So this is the area now which we are talking about, and this is the Z area here. This is the Z area. So Z is equal to 50 of X1 and 30 of X2. Okay, that is the Z area. Any question on that? All things are just clear. Anyone who wants to say something?
Excuse me, sir.
Yes, please.
Pardon.
Pardon on what?
On this maximization, Z is equal to 50 x1 plus 30 x2.
Okay. Let me do like this, okay? So if that first stick there represents 10, okay? Then another stick there represents 10, okay? And we have another one represents also 10, okay? So this is 10, 20, 30. And we are told from this equation, X2 is 30, okay? So it means when we stop at 30, we stop, okay? Because we are taking 30 of X2. Now this is 10 of X2. This is 20 of X2. This is, remember, this is 0 of X2. So this is 0 of X2. So from here, we have 10 of X2. We have 20 of X2. Then we have 30 of X2. Then we come to this other side. Again, we have 10 of x1. Then we have 10, 20 of x1. Then we have 30 of x1. Then we have 40 of x1. And then we have 50 of x1. Okay? So according to our equation, we are told when we reach 50 of x1, we stop. Okay? On this side. And on the upper side, when we reach 30 of x2, we stop. Now, these two, we have been told to add this point, that which is this point, which is 30x2. Then we add it to this point, which is 50x1. Okay? But we are saying x1 can be 0 or greater than 0. So it means from here up to here, that means anything below 0 cannot be x1. And x2 can be 0 or greater than 0. Okay? So it means anything below 0 cannot be x2. So which means this is the point. So now this area here now becomes the z. Is it more clear now? Yes, it will come clearer when we start doing the real programming. These things are going to come back when we do the objective functions and the constraints. It will come clear. I don't know, it is a bit confusing, but this is now mathematics. This comes from the mathematics, which I told you that linear programming comes from students who are doing engineering, mathematical engineering. So that's why it is confusing. But for us here, what we want to pick is we need to use this knowledge in coding, in programming. Okay? We shall do bounds. I have a slide down there on bounds. It will come clear. Now, this is the example of the carpenter, which I gave you, which I told you about already. Okay, when we talk about bounds, so bounds refer to the limits. So when you talk of a bound, it means a limit or constraint. I gave you an example, and I told you a Muslim man can marry up to 1, 2, 3, 4 women. That is a limit. Okay? So when it comes to 4, yes, you are Muslim, yes, we understand. We allow you to marry the first one, we allow you to marry the second, we allow you to marry the third, but we can't exceed the fourth. That is the limit. That is a boundary which has been given. Okay? But a Catholic man, you are allowed to marry only one, and that is the limit. That is the boundary. Okay? So in programming, as you write your codes, you are going to put a limit. Okay? Like look at the clock. You look at a clock. The seconds hand is going to move. When it reaches 60, then it is going to count that is 1 minute. So that is a limit which was given by the programmer who was programming that clock. That when you reach 60, that is the limit. Then you go back to 1. When you reach 60, that is 60 seconds. It makes a minute go back to 1. And now when the minute hand goes and reaches 60, then that is 1 hour. Okay? Then you go back. That is the limit. So in your programming, you are going to be putting those limits. If you go back to the traffic lights, okay, you have put a limit that the green, when it is on green, it is going to count 10 seconds. So it will count 1, 2, 3, 4, 5, 6. When it reaches 10, it goes to amber. And on amber, it will count 3 seconds, then it goes to red. Okay? So on green, you have given it a limit of 10 seconds. Amber, you have given it a limit of 3 seconds. And red, you have given it a limit of 10 seconds. After 10 seconds, then it goes back to green. And the process continues. So that is what we call bounds. In programming, you are going to give limits of your code. Okay? You just look at a phone. When it starts ringing, it has been given a limit of 45 seconds to ring. After 45 seconds and it's not picked, it is going to say the person cannot pick up the call, try again later. Okay, that is what was programmed. If they programmed it for to ring for 2 minutes, again to ring for 2 minutes. Okay, so that is what we call a limit or a constraint. So limits or constraints within which a certain variable, data structure, or operation is valid or can function. So we shall have these bounds as we go ahead, and we shall see what they mean. We shall have the array bounds, we shall have the variable bounds, function bounds, memory bounds. We shall come back to these terminologies and we shall see what they mean. Now I'm going to give you a question. Get a pen and a paper and write down. Get a pen and paper and write this one down. So it is, why do bounds matter in programming? Why do bounds matter in linear programming or in programming? Why do bounds matter? So you can go and read about that in your free time. Why do bounds matter? So understanding and correctly implementing bounds in programming is crucial for writing safe code, a reliable code, and an efficient code. If you can check on ChatGPT, that one I got it from ChatGPT. So ChatGPT says understanding and correctly implementing bounds in programming is crucial for writing a safe code. Why do we say safe code? Because if your traffic light was not given a limit for the green light, people, one time I remember I was driving, was it around Nankulabi, and they were repairing those traffic lights. And the green was on continuously on one side, and on the other side, the red was on continuously. And we didn't know what to do. Until when these people are working on them, just started telling us, you go, you go, you go, you go. Because one side was moving and there was a lot of cars parked on the other side because the other side was on red. And the other side were no cars. The people were just driving and everybody was wondering. So because the people who are working on them had not put a limit. Okay. So for writing a safe code, a reliable code, and an efficient code, that's why we need bounds. That's why we need limits. Okay. Can you imagine if a Muslim man was not limited to 4 women? What would happen? If a Catholic man was not limited to 1 woman, what would happen? If a Muslim woman was not limited to be married to 1 man, what would happen? So sometimes we need these limits in order to be controlled. So that diagram which you see there shows you the bound and the feasible region. Okay. So from 0 to X, that is the region and that is a bound. If this was a container of water, it means that water has reached is within that container and shouldn't go out. Okay, again, when you talk about constraints, when you look at that picture there, some of you, this is how your parents used to control you when you're crowing. Okay, they used to tie you on the bed. When your parent doesn't want you to disturb them, some of you have tied your young ones at home on the pillar. You don't want them to crow. You want them to be just within that area. So you tie them. So that is a constraint which stops you from going beyond. Okay. Some of you, your parents have locked the gates. You have been in senior 6 vacation. Your mom, your dad doesn't want you to go astray. Some of you have been locked up in the gate. They say, what haven't you bought? You have given everything. They lock you up in the gate so that you're within the boundaries. You don't go outside. Okay. So that is what we call a constraint, and that's what we call a boundary. And down there we say constraints in daily life are just the boundaries you set. Okay. The boundaries you set in daily life. You may be a girl and you say, me, I don't want to be dated by border riders. That's the boundary you have set. Okay. I'm a girl, yes. I'm looking for a man, but if you are riding a border, I don't want. Me, I want a man who's driving a car. That's a boundary you have set. That's a constraint. So if you are driving a border, don't come near me. Okay. And when we look at constraints, they lead to what to get quality. Like when you see this diagram, when you see the scope, the time, and the cost, they form what we call quality. In order for you to get quality, you have to have a scope. You have to have a time period, and you have to know the cost. So in other words, you get what is called quality. Okay. Another question for you, which I want you to work on, that is why linear programming anyway. As students of computer science, why are you studying linear programming? Okay. That is another second question I want you to work on. Why linear programming? Okay. Do we need any linear programming as students of computer science? Okay. Also write that question down. Okay, so I got the last slide. Last slide, which says, for an information systems and technology student or computer science students, linear programming isn't just mathematics. Remember, I told you linear programming comes from mathematics. So for you, it isn't just mathematics, no. Okay? For you, it's not the mathematical bit of it, but a toolkit for building smarter systems. So we are going to use linear programming to build smart systems, make better decisions, and delivering IT solutions that save time, save money, and resources. Like the app which I told you for my borrow money, it has saved people a lot of money. Instead of boarding a taxi to take 10,000, you use 20,000 to take 10,000, you just send it on mobile money. Okay? So it saves time, it saves money, it saves resources. Okay? So this is what is ahead of you as computer science students in linear programming. Yes? Any questions so far? Any question? Are people still alive?
Yes, sir.
Okay, I'm sharing another screen. Can you see the new screen I've shared? Yes?
Yes.
What is on the screen? What can you see on the screen?
Introduction to Python programming.
All right. So I have introduced you to linear programming, and I've told you it brings in mathematics, but we are not going to take the mathematical direction in this course unit. The mathematics, we are going to leave it to students who are doing engineering, electrical engineering, and mechanical engineering. So we are leaving it to them. So for us, we are going to take the direction of real programming, and we are going to choose a programming language which is called Python programming. Okay? Python programming. So I'm going to give you this textbook in the group, and is the official textbook which we are going to use for Python programming. So I want you to read chapter 1. By Tuesday next week, when we come for the lecture, everyone should have gone through chapter 1 of this book. As you see, I'll go very fast because we don't have enough time to cover everything. Okay? I'll not handle everything in class. I'll assume you have gone through, and I'm just making things clearer. Someone made me up already on this group. He told you should learn how to read the notes and understand them. Who was that one? Who put that in the group? Who said people should learn how to read notes and understand them? So let us read chapter 1, understand it. You can also form a group. You can form a study group. You don't need to be with the lecturer. You can form a study group and you go through each subsection as a group. Or you can say so and so, like you can say Innocent, you do subsection 1, then Rachel do subsection 2, then and so on. Then together you come, Innocent tells you what you read, Rachel tells you what you read, then together you come up. When the lecturer comes, we just make things right. Okay? That is one textbook we are going to use. I'm going to share a second textbook which we shall use in this course unit. I'm going to share a second textbook. So I'm going to show you everywhere where we have the material which we need in order to pass this course unit. So the second textbook which we are going to use is, so you go to Google, okay? So you go to Google and then you type there W3 schools, W3 schools Python, okay? W3 schools Python. So you click on Python tutorial. So again, this is another, all the notes are there, which are going to help us to learn this course unit. All the notes are there, okay? When you look on the left here, we have all the notes. We have introduction. So you have the variables. So I want you to read about all the variables. Your friends on the main campus, they're already ahead of you. With them, we have already completed these variables. So for you are a bit behind, but I want you also to catch up. Main campus, we have already done the variables, and for them, they have already started writing some codes and they are happy. Okay. So I want you also to get there soon. So I have shown you everything where it is. There are some exercises. Every chapter has some exercises. It has where when you click on the button, which is try it yourself, it is going to give you a white screen where you can write a code. Then you run. When you run your code, you will see it on a black screen running. Okay. Like for example, if I change that name there and I put something else and I say run, you're going to see it is going to change and it's going to put what I have put. See? Okay. So let me stop sharing that screen also. Okay. Any question? Any question? Are people still there or they are lost? Yes? I'm waiting for questions before I end the lecture.
So,
Yes, please.
so even next week shall have an online lecture or physical.
I will tell you, normally I communicate. If it is physical, but hopefully next week we shall have a physical lecture. Normally, today it was supposed to be physical, but the challenge is I had an appointment with a doctor, which I had not put into consideration. Okay. But hopefully next week we shall have it physical. Any other question?
Okay.
Yes? Can we call it a day? Okay. We can call it a day. I've given the reading material, people. Okay. Programming is not easy. Okay. Programming is not easy. Writing a code is not easy. You must go out of the joking environment. Okay. and start being serious students. These things of coming to the group, say, yeah, man, you are talking like hooligans on the group. It will not help. Now I expect you to be putting on a code in the group that I am trying out this, but I have failed. Can anyone help me? But when I see people talking like hooligans on the group, I'll block you and I stop you from posting anything on the group. Okay? So normally I do that. When I see students who are not serious, I just block them. For me in my class, I need only serious students. These students who are talking like hooligans, let's leave that to the marketplace on the streets. Okay? In my classes, I don't entertain nonsense. And that is me. I need only serious students. From now onwards, make sure what you are putting on a group is sense. Put nonsense, I'll kick you out of the class. Trust me. Any students who puts nonsense in the group, I'll kick you out of the class. We need only serious content to deal with programming. Okay. I wish you the best. Have a nice evening.